Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who loves to drift towards sleep with a little wonder, letting thoughts of distant futures replace the noise of daily life. There's nothing you need to do right now but rest. Let your shoulders soften, your breathing slow, and your mind grow gentle. Because tonight, we're not just closing our eyes, we're traveling forward through time into the quiet dream of what humanity may become among the stars. From our first small steps into deeper space, to glowing cities on distant moons, to technologies that feel almost like whispered magic. We'll explore 100 sleepy facts about the future of space, designed to soothe you, inspire you, and help you drift into peaceful dreams. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, let the world soften around you, and let's begin. Fact 1. The dawn of the spacefaring era. Long before humanity truly drifted beyond Earth, there was a quiet understanding that the stars were not unreachable, only waiting. The future of space begins with this gentle shift in perspective, when our species first learned to look upward, not with fear, but with curiosity softened by time. As technology matured and our dreams grew steadier, we began to lift ourselves, calmly and deliberately, into the wider dark. In the years ahead, this moment will be seen as the dawn, the subtle glow before the sunrise of a spacefaring civilization, a time when rockets became tools of exploration rather than spectacle, and space itself became a calm extension of our home. And from that early light, the journey only expands further into the quiet beyond. Fact 2. Quiet engines, distant horizons. In the future, the engines that carry us into space will whisper rather than roar. Instead of explosive fire and thunder, most deep space travel will rely on slow, steady pushes, gentle streams of ions or plasma drifting backward like faint blue mist. These engines don't hurry. They nudge, patiently building speed across weeks and months until a ship is gliding faster than we can easily imagine. It's a kind of travel that feels almost meditative. No rush, no urgency, just smooth, continuous acceleration through the velvet dark. Travelers will watch the stars drift almost imperceptibly as the engines hum a soft, constant note. And with each quiet pulse, the horizon pulls a little farther open, inviting us deeper into the cosmos. Fact 3. Harnessing sunlight for the journey. Ahead. For much of our early exploration, sunlight was something we simply basked in, rarely considering its hidden potential. But in the future, spacefarers will rely on the gentle power of starlight itself. Vast, shimmering solar arrays will unfurl like metallic petals, catching photons that have been traveling for thousands of years. Even far from Earth, these delicate wings will gather just enough energy to keep life warm and systems running. Some ships will travel with sails so thin they ripple at the touch of light, using radiation pressure as a breath of wind. Others will carry spiraling fields that concentrate sunlight into brilliant beams of propulsion. In both cases, the sun becomes not just a beacon, but a companion, guiding us softly toward the worlds that wait in its distant glow. Fact 4. The whisper of ion propulsion. In the future, many spacecraft will glide forward using ion propulsion, a technology that feels more like a whisper than a push. Instead of burning fuel in loud, violent bursts, ion engines release charged particles one by one, sending them drifting out into space like tiny luminous grains. Each particle carries only the faintest nudge, but together, over long stretches of time, they craft a steady, peaceful acceleration. These engines glow with soft blue light, barely brighter than a candle, yet they can push a ship to remarkable speeds once the gentle thrust compounds. Travelers may hardly feel the motion, as though the ship is floating through a dream. In this quiet way, ion drives lead us smoothly into deeper space, one glowing breath at a time. Fact 5. Fusion dreams lighting the dark. Far ahead, in our future, fusion engines may become the warm heart of interplanetary travel. They draw their power from the same process that lights the stars, the combining of tiny nuclei into something greater, releasing energy with a brilliance both fierce and controlled. But aboard a ship, it will feel serene, a contained sun humming softly in a chamber, offering more power than anything we've used before. Fusion propulsion won't roar. It will thrum with a steady pulse, a rhythm so deep it might blend with the ship's natural vibrations. With each pulse, the craft will push forward with a strength that could shrink journeys from months to weeks. And as that quiet star burns gently inside its metal cradle, the darkness around will seem just a little less cold. Fact 6. Sailing on starlight itself. One of the most elegant forms of future travel needs almost nothing at all, just the patience to ride the pressure of light. Solar sails, thinner than a human hair, will unfurl from spacecraft like glimmering sheets of silver. They will stretch wide into the vacuum, catching sunlight the way a paper lantern catches a breeze. The push is so gentle, it's almost poetic, yet over time, it can carry a ship across millions of miles. Passengers may watch the sail ripple slightly as photons, ancient and tireless, tap against its surface. No fuel, no noise, no hurry, just the steady touch of starlight, urging the ship onward with the faintest hand. And drifting beneath that shimmering sail, humanity will feel the artistry hidden in simple light. Fact 7. The era of reusable starships. In the future, starships will be built not as disposable machines, but as trusted companions meant to fly again and again. Their frames will be crafted from resilient alloys that shrug off heat and cold, able to slip between atmosphere and vacuum without strain. These ships will rise from Earth on quiet engines, return gracefully, and then, after gentle maintenance, soar outward once more. Because of this reusability, the sky will feel less distant. Launches will become routine, almost calm events, like ferries drifting from shore to shore. Each flight will carry supplies, explorers, and curious travelers into the ink-black sea above, with a steady rhythm humanity can rely on. And with every returning ship, our connection to the cosmos will feel just a little more familiar. Fact 8. Refueling. Among the celestial seas, to travel far from Earth, future spacecraft will no longer have to carry all their fuel from home. Instead, they'll glide to quiet depots orbiting the Moon, Mars, or distant asteroids, gentle way stations floating in the emptiness. These orbital harbors will store frozen propellants gathered from water ice or synthesized from starlight-driven reactions, waiting patiently for the ships that depend on them. A vessel might arrive slowly, latch on with soft magnets, and take what it needs to continue its long journey. Refueling will become as peaceful as docking at a lakeside pier, surrounded not by waves, but by the shimmering silence of space. With these scattered depots, our reach grows longer, turning the vastness into a chain of familiar resting points, one quiet orbit at a time. Fact 9. the cosmic shipping lanes of tomorrow. As space traffic grows, invisible pathways will form through the solar system, gentle arcs shaped by gravity, sunlight, and time. These will become the cosmic shipping lanes of tomorrow, used by cargo craft drifting steadily along predictable routes. Instead of rushing, they will follow energy-efficient trajectories, letting gravity assist their motion like soft currents in a celestial sea. Freighters will depart Earth in a slow procession, their holds filled with materials, equipment, and treasures gathered from the moon or asteroids. They'll glide past planets in graceful loops, nudged by gravitational tides, saving fuel with every quiet maneuver. Over time, these routes will weave a delicate web across the inner solar system, connecting worlds with a steady, patient rhythm, a cosmic trade wind guiding travelers between distant harbors. Fact 10. AI navigators guiding the long drift. In the future, spacecraft will sail with digital navigators, calm, tireless intelligence woven into their systems. These AI companions won't command with urgency. They will simply watch, calculate, and gently adjust a ship's course through the changing pull of planets and the faint pressure of light. They'll guide journeys that stretch across months or years, tending to the vessel the way a quiet caretaker tends a garden. Their focus will be constant yet unobtrusive. A subtle correction here, a soft suggestion to the crew there. And in the long silence of deep space, their presence will feel like a steady heartbeat, reassuring and warm. With these gentle minds at our side, even the vastness will feel a little more navigable, a little less lonely. Fact 11. Soft footsteps on lunar soil. Again, humanity will return to the moon, not as visitors passing through, but as residents learning its rhythms. The first steps of this new era will be soft, deliberate, taken by explorers wearing suits designed for long, quiet strolls across the powdery regolith. Each footprint will linger for centuries, marking the beginning of a calm and enduring partnership with our nearest celestial neighbor. In the gentle light of the lunar dawn, crews will move slowly across gray plains, checking instruments, surveying horizons, and feeling the strangeness of low gravity tugging lightly at their bodies. Far above, Earth will glow like a blue lantern in the dark, and those early footsteps will signal the start of a new home, one built with patience and intention on the edge of forever. Fact 12. Moon bases, built from dust and light. Future lunar habitats will not need to import everything from Earth. Instead, they'll rise from the moon's own soil, using 3D printers that melt regolith into sturdy blocks and curved domes. These structures will be rounded and quiet, insulated against radiation and temperature swings by layers of solidified dust. Inside, warm lights will glow softly against pale walls, creating pockets of comfort in a landscape of silence. Solar panels stretched across nearby ridges will gather sunlight with steady, dependable grace. Together, these humble materials, dust and light, will support laboratories, living quarters, and tiny greenhouses where life can take root. And from these gentle beginnings, a small lunar village will grow, preparing humanity for greater stretches into the cosmic sea. Fact 13. Water ice, hidden in silent shadows. In the quiet craters near the moon's poles, where sunlight never quite reaches, small reserves of water ice rest untouched. These frozen pockets have waited for billions of years in perfect stillness, preserved by the eternal cold. In the future, explorers will gently harvest this ice, not with loud drills or harsh tools, but with soft, careful methods designed to protect the delicate environment. The ice will be melted into drinking water, split into oxygen for breathing, and transformed into fuel that can carry ships farther into space. It's a gift from the moon itself, a quiet resource hidden in shadowed corners. And with every drop gathered, the lunar settlements will grow more self-sufficient, rooted slowly in their ancient frozen wells. Fact 14. Lunar greenhouses blooming slowly. Though the moon may seem barren at first glance, future settlers will coax small gardens to life behind protective glass. Inside these lunar greenhouses, plants will unfurl their leaves under soft artificial sunlight, swaying gently in the lighter gravity. Roots will nestle into nutrient-rich substrates, recycled and purified through careful systems designed for harmony rather than waste. These gardens will not be vast, but they will be precious. Tiny islands of green in a world of silver dust. Astronauts may sit beside them during long evenings, listening to the faint hum of water pumps and feeling the quiet comfort of life growing steadily nearby. And with each new sprout, the moon will feel a little less foreign, a little more like a place where humanity can breathe and dream. Fact 15. The moon as humanity's cosmic harbor. In the years ahead, the moon will become more than a destination. It will serve as the solar system's first harbor, a gentle midpoint between Earth and the deeper worlds beyond. From its surface, launching spacecraft requires far less energy than from Earth, making it a natural gateway for journeys to Mars, asteroids, and even the outer planets. Future travelers will pause here, refueling, repairing their ships, and preparing for the quiet stretches of space that lie ahead. The moon's infrastructure will feel almost like a peaceful port town. Calm lights glowing in the darkness, soft beacons guiding vessels in and out. From this harbor, humanity will step outward with confidence, knowing they are never too far from a familiar refuge in the celestial sea. Fact 16. Quiet laboratories beneath the regolith. As lunar settlements grow, scientists will build their laboratories beneath thick layers of regolith, sheltered from radiation and micrometeorites. These underground rooms will feel calm and insulated, their walls carved into gentle curves that soften the harshness of the lunar landscape. Inside, instruments will glow with soft blue and amber lights, quietly measuring the moon's chemistry, its seismic murmurs, and the subtle composition of ancient rocks. Researchers will move slowly in the lower gravity, their footsteps soundless on padded floors. Experiments that are difficult on Earth will be easy here, where fragile systems can float weightlessly and delicate measurements unfold without interference. And in those peaceful chambers, humanity will begin to understand the moon, not just as a destination, but as a world with its own quiet stories to tell. Fact 17. Telescopes in the cratered stillness. Future astronomers will place giant telescopes inside deep lunar craters, where the moon's far side shields them from all the noise of Earth. In this pristine silence, mirrors will stretch wider than anything we've built before, collecting faint whispers of starlight that have crossed the universe for billions of years. With no atmosphere to blur their vision, these observatories will gaze with incredible clarity. Scientists will process the data from warm, softly lit rooms nearby, watching new galaxies emerge on their screens like watercolor blooms. Every night, the telescopes will turn gently, following cosmic rhythms with patient precision. And from this cratered stillness, our understanding of the universe will grow deeper, revealing wonders we've only guessed at until now. Fact 18. Molten dreams, extracting lunar metals. Beneath the moon's dusty surface lies a wealth of useful metals, iron, aluminum, titanium, waiting for future settlers to uncover. But instead of harsh mining techniques, humanity will use gentle processes that melt regolith with focused sunlight. Vast mirrors will concentrate beams into small furnaces, turning solid dust into shimmering pools of molten material. From these pools, metals can be separated and shaped into beams, plates, and tools, all crafted in the low gravity of lunar foundries. The work will be quiet, almost meditative, as molten streams are guided into molds that cool slowly under the star-filled sky. And with each crafted piece, the moon will become more capable of supporting new habitats, machinery, and pathways into deeper space. Fact 19. The calm glow of lunar power. Grids on the moon. Future power grids will stretch quietly across the gray terrain, capturing sunlight with serene efficiency. Long rows of solar panels will climb ridgelines where dawn lingers longest, their surfaces glinting like still water beneath the rising sun. These panels will feed steady streams of energy into buried cables, keeping habitats warm, greenhouses bright, and scientific instruments humming softly through the long lunar nights. Some areas will use molten salt batteries or underground thermal stores, gently releasing heat to sustain life during the 14 days of darkness. The entire system will feel more like a breathing organism than a machine, drawing in light, holding it close, and releasing it slowly. And under this calm glow, lunar communities will thrive with a quiet, dependable warmth. Fact 20. A sleeping city on the night side of the moon. As settlements expand, one of humanity's earliest lunar cities may be built on the moon's night side, where darkness lasts for weeks and the stars shine with flawless clarity. Homes and research domes will nestle into the landscape like softly glowing lanterns, shielded under layers of regolith. Residents will move through quiet, interconnected tunnels warmed by geothermal storage and solar reserves collected during the previous day. Life here will follow a gentle rhythm. Long nights will bring extended periods of rest, study, and reflection, while the bright lunar days will fill the city with renewed energy. Outside, rovers will glide silently over frozen ground, their headlights sweeping across distant hills. And in this sleeping city, humanity will learn how to flourish in a world lit mostly by the soft shimmer of starlight. Fact 21. The first human sunsets on Mars. Eventually, humanity will place its first gentle footprints on the dusty plains of Mars. And one of the most unforgettable moments will be watching a Martian sunset, a small, delicate glow that colors the sky with soft blues instead of fiery reds. As the sun sinks below the horizon, its light scatters through the thin atmosphere, creating a pale halo that lingers quietly in the cold air. Explorers will stand in their pressurized suits, feeling the faint tug of Martian gravity as they watch the light fade. The landscape will stretch around them in muted golds and rust tones, peaceful and untouched. That first sunset will feel like both an ending and a beginning, a calm acknowledgement that we have truly arrived on a new world. And as darkness settles, Mars will open its vast, silent frontier for us to explore. Fact 22. Homes pressurized against the red silence. On Mars, future homes will not stand tall like Earth's buildings, but will nestle low into the soil, shaped to withstand the quiet, unearthly cold. These habitats will be pressurized gently, their walls layered with insulation and regolith shielding to keep the thin Martian atmosphere at bay. Inside, Lights will glow in warm tones, casting soft reflections on curved corridors and rounded living spaces. Residents will move through airlocks as naturally as stepping through a doorway, breathing recycled air that has been purified and refreshed through careful filtration systems. The silence outside will feel immense, almost tender, while inside the gentle hum of life support systems will offer constant reassurance. And in these sheltered homes, humanity will begin to build a peaceful existence on a world once thought forever unreachable. Fact 23. Martian soil, patient and ancient. Beneath every footstep on Mars lies soil that has waited for billions of years. Unlike Earth's lively dirt, filled with roots and insects, Martian regolith is dry, mineral-rich, and shaped by winds that whisper slowly across the plains. Future settlers will study this ancient dust with quiet reverence, learning how it formed and how it can support the fragile beginnings of life. Scientists will heat samples gently, searching for traces of salts, ice crystals, or carbon compounds. Over time, they will learn to turn this patient soil into something more helpful, a foundation for bricks, a source of building materials, or a substrate enriched for plants. And as humanity works with Martian soil, it will feel like forming a calm partnership with a world shaped entirely by time and silence. Fact 24. Winds, whispering across empty plains. The winds of Mars are softer than they appear in old science fiction tales. Though they can stretch for great distances, the air is so thin that even a strong gust feels like a gentle breeze. These winds move fine dust across the plains, painting dunes in slow, shifting strokes. Future settlers will listen to them through insulated helmets, hearing only the faintest murmur. Out on the open landscape, dust devils will rise like quiet spirals, turning lazily before fading into the distance. Rovers and explorers alike will learn to read the patterns of these breezes, how they shape the land, how they travel with the changing seasons. And with each whispering wind, Mars will reveal a little more of its personality, guiding humanity deeper into its ancient calm. Fact 25. Greenhouses under rust-red skies. On Mars, future greenhouses will glow softly like warm lanterns scattered across a cold desert. Their transparent shells will protect lush, emerging gardens from harsh radiation and swirling dust. Inside, plants will reach upward under full-spectrum lights, their leaves stretching slowly in the gentle pull of Martian gravity. Small fans will circulate the air in delicate currents, helping stems grow straight and strong. Workers will move between rows with quiet care, checking moisture, adjusting nutrients, and watching the subtle rhythm of life unfold. These greenhouses will not just provide food, they'll offer comfort, a vivid reminder of Earth's colors and scents. And as each new sprout reaches toward the artificial sun, humanity will feel just a little more rooted in its red, distant home. Fact 26. Melting the polar ice for tomorrow. The Martian poles hold vast stretches of frozen water and carbon dioxide, preserved in layered ice caps that shine pale beneath the thin sunlight. In the future, explorers will approach these frozen reserves with gentle, deliberate technologies, not to disrupt them wildly, but to tap small amounts for early settlements. Heated probes may melt narrow channels, guiding water into insulated tanks where it can be stored and shared. This water will nurture crops, provide drinking supplies, and form the basis of fuel for voyages farther into the solar system. Scientists will study the ice as they work, reading its layers like pages of an ancient diary, each stratum revealing past climates, storms, and long-lost seasons. And with each careful extraction, Mars will slowly offer the resources needed to grow new kinds of life beneath its skies. Fact 27. Cities in lava tubes, nature's shelters. Deep beneath the Martian surface lie vast lava tubes, natural tunnels carved long ago by flowing molten rock. These caverns, some wide enough to hold entire neighborhoods, offer protection from radiation, micrometeorites, and the wild temperature swings of the surface. In the future, settlers may transform these ancient halls into quiet, sheltered cities. Warm light panels will line the ceilings, mimicking gentle daylight. Hydroponic gardens will wind through the corridors, adding softness and color to the stone surroundings. Homes, laboratories, and small parks will be built along smooth, curved walls, making the underground world feel surprisingly welcoming. And as people gather in these calm, echoing spaces, they will find comfort in the natural strength of the planet itself, a hidden refuge patiently waiting beneath the red dust. Fact 28. The rhythm of souls, Martian days. A day on Mars, called a sol, lasts just a little longer than a day on Earth. 24 hours, 39 minutes, and 35 seconds. This gentle difference will shape the rhythm of life for future settlers. Their clocks will drift slightly slower, their routines stretching with the quiet patience of the red world. Each morning, sunlight will rise with a softer hue, painting distant hills in pale gold before warming the valleys below. Inside habitats, lights will follow the Martian rhythm, gradually brightening and dimming in harmony with the outside world. Over time, settlers may come to appreciate the slower tempo, a subtle pause built into the turning of the planet. And with each sol, Mars will feel a bit more familiar, its days becoming the gentle heartbeat of life far from Earth. Fact 29. Mars ports for the interplanetary fleet. In the future, Mars will host its own spaceports, calm, spacious facilities built on flat terrain where ships can land and depart with graceful precision. These Mars ports will be hubs of quiet activity, filled with soft hums from life support systems and the low glide of autonomous cargo rovers carrying supplies. Launch pads will be designed to minimize dust plumes, using methods that gently lift ships without unsettling the fragile environment. Travelers preparing for departure will gather in pressurized lounges, watching the landscape through wide windows that frame rust-red horizons. Arrivals will be greeted by warm lights, steady airlocks, and the comforting presence of green plants lining the corridors. A soft welcome in a stark world. And from these ports, ships will glide outward toward moons, asteroids, and even deeper destinations, weaving Mars into the growing network of human exploration. Fact 30. Terraforming, a dream. Still in the distance. For generations, people have imagined warming Mars, thickening its atmosphere, and turning its deserts into places where forests might someday sway. But in the future, Mars will teach us patience. Terraforming will remain a distant dream, unfolding over centuries rather than years. Large mirrors might redirect sunlight to warm small regions, or microbes may be introduced slowly, step by careful step. Instead of rushing to change the planet, humanity will learn to adapt to its current nature, building habitats, tending greenhouses, and nurturing small patches of life within protective domes. The dream of a blue-tinged Mars will remain a quiet, hopeful vision, guiding research with gentle curiosity rather than urgency. And as we imagine what Mars may one day become, we will find beauty in the long journey ahead, resting in the knowledge that some transformations take time. Fact 31. Floating cities in the upper atmospheres of Venus. One day, humanity may drift through the skies of Venus, not on its scorching surface, but far above it, where temperatures and pressures are surprisingly gentle. Here, in the cool upper atmosphere, floating cities could ride the winds like quiet ships on a golden sea. Their structures would be buoyant, filled with breathable air that naturally lifts them into calm, stable layers of cloud. Inside these skyborne habitats, settlers would live in softly lit rooms, surrounded by panoramic windows showing endless waves of cream and amber clouds. The sunlight, filtered through the thick Venusian atmosphere, would cast everything in a warm, dreamy glow. And as these floating cities drift slowly along the planet's gentle winds, humanity would find a peaceful home in a place once thought impossibly hostile. Fact 32. Cloud habitats, drifting in gentle light. Cloud habitats on Venus would move with the serene grace of lanterns carried by a soft breeze. Suspended high above the turbulent lower layers, they would follow steady wind patterns that circle the planet every few days. Residents might wake to a horizon washed in pale gold, watching sunlight ripple across the cloud tops like shimmering silk. Inside, gravity would feel similar to Earth's, offering comfort during long stays. Life support systems would quietly recycle air and water, using solar energy gathered from vast arrays that glint brilliantly in the bright Venusian sky. Gardens could thrive here too, their leaves gently swaying with the slow shifts of the floating platform. And as these habitats drift in their perpetual sunrise, they would serve as peaceful beacons of exploration, showing how humanity can adapt to even the most unlikely worlds. Fact 33. Listening stations on Mercury's shadowed craters. Mercury, often imagined as a world of constant heat, hides cool sanctuaries within its polar craters, deep, permanent shadows that never touch sunlight. In these frigid basins, future explorers may build listening stations shielded from solar glare and cosmic interference. The extreme quiet would make them perfect for radio astronomy, allowing gentle signals from distant galaxies to arrive unspoiled. These outposts would be small and sturdy, nestled into the crater walls like sleeping birds tucked beneath a ledge. Solar panels along the rim would gather energy, sending it down by cable to illuminate warm interior rooms where scientists could work in comfort. Outside, the darkness would stretch endlessly, lit only by the faint sparkle of distant stars. And within this tranquil silence, Mercury would become a humble gateway to hearing the universe's softest whispers. Fact 34. Orbital habitats, spinning, soft gravity. In the future, many people may live in large orbital habitats, gentle, spinning structures that create artificial gravity through rotation. Inside, the world will feel familiar. Floors beneath your feet, water flowing calmly, plants growing in long green arcs. Yet outside every window, the universe will drift in quiet motion. Stars will not twinkle here. They will shine with pure stillness, set against the deep velvet of space. The rotation will be slow enough to feel natural, a subtle pull that keeps the body grounded. Residents may stroll through gardens arranged along curved corridors, their footsteps echoing softly in the spacious interior. Streams of sunlight, reflected by enormous mirrors, will illuminate entire neighborhoods suspended inside the rotating cylinder. And in these serene, spinning worlds, humanity will discover new ways to feel at home among the stars. Fact 35. Asteroid settlements, Carved from stone, deep within certain asteroids, humanity may carve out quiet sanctuaries, protected chambers shaped from ancient rock older than Earth itself. These hollowed spaces will be lined with warm light panels, transforming rugged stone into gentle, livable environments. Low gravity will give movement a dreamlike quality, as settlers glide rather than walk from one room to another. To create these habitats, robots will first map the asteroid's interior, choosing sections stable enough for long-term use. Once carved out, the chambers will be sealed, pressurized, and filled with breathable air. Slowly, life will spread through these enclosed caverns, hydroponic gardens, research stations, small homes nestled into the rock. And as people adapt to these peaceful, carved-out worlds, they will find a quiet connection to the most ancient matter in the solar system. Fact 36. Rotating cylinders filled with forests. Among the most beautiful visions of future space living are the rotating cylinders inspired by early dreamers of orbital life. These vast structures may one day hold entire forests inside. Tall trees swaying gently with the rotation, grasses rippling in long spirals beneath a painted sky. Artificial sunlight will sweep across the interior in soft, warm cycles, nurturing life in a giant, enclosed ecosystem. People will wander along curved landscapes that wrap seamlessly over their heads, creating the illusion of endless green. Rivers will flow in quiet arcs, held in place by centrifugal force, while birds and insects adapt to the gentle pull of this engineered gravity. The entire habitat will move with a slow, steady rhythm, like a cradle drifting in cosmic stillness. And inside these living cylinders, humanity will rediscover the calm beauty of nature, carried with us wherever we roam. Fact 37. Cosmic gardens, growing in starlit domes. In the future, humanity will carry its love of green spaces far into the cosmos. Across moons, asteroids, and drifting habitats, great domes will shelter cosmic gardens, places where soft leaves, delicate blossoms, and winding vines grow in peaceful harmony. Artificial sunlight will filter through curved glass panels, creating warm, dappled patterns that sway gently with the passing hours. Inside these domes, the air will be rich with the scent of soil and growing things, a comforting reminder of Earth's gentle forests. Settlers may visit during long evenings, resting beneath broad trees while distant stars shine overhead. Children will learn to care for alien-adapted plants, watching them curl and flourish in reduced gravity. And in these gardens, life will feel balanced again, a quiet oasis carried across the vastness of the solar system. Fact 38. Habitats linked by solar railways. As humanity spreads across space, our many settlements, floating, buried, domed, and carved, will be connected by slow, steady streams of travel powered by sunlight. Solar railways won't need rails at all. Instead, there'll be networks of paths shaped by predictable orbital motions and gentle propulsion. Cargo vessels will drift along these patterned routes, nudged occasionally by photon sails or electric thrusters powered by captured sunlight. From above, it will appear almost like a dance, dozens of small ships moving gracefully between worlds, their paths shaped by gravity and light. These routes will be reliable, calm, and fuel-efficient, turning the solar system into a web of softly glowing trade lines. And as vessels glide along these sunlit highways, humanity will feel the first hints of a connected cosmic society. Fact 39. Giant reflectors, bringing daylight to the dark. Some settlements, especially those tucked in shadowed craters or deep valleys, will rely on enormous reflectors to guide sunlight into places where it never naturally falls. These mirrors will float gently in orbit or rest on tall towers, angled with careful precision. They will catch beams of distant light and redirect them into communities that would otherwise live in perpetual dusk. When the reflectors turn, a soft glow will spill across the landscape, warming the ground and illuminating structures with a calm, golden sheen. Residents may watch as the mirrors shift slowly throughout the day, following the sun's steady arc across the sky. And with each reflected ray, humanity will bring a little more warmth and comfort to the quiet corners of its expanding home. Fact 40. The first truly artificial worlds. In the distant future, humanity may begin crafting entire worlds from scratch. Tranquil, engineered spheres built in the empty spaces between planets. These artificial worlds will be carefully designed ecosystems shaped with deliberate patience. Soft gravity, adjustable climates, and endless horizons painted across curved interiors will create places where life can flourish in perfect balance. Inside, gentle rivers will wind across landscaped valleys, flowing in serene loops held in place by careful engineering. Communities will settle beneath softly glowing skies, their light calibrated to mimic dawn and dusk in slow, calming rhythms. The entire world will breathe in harmony, powered by sunlight collected in shimmering arrays that wrap around the exterior. And drifting quietly through the solar system, these crafted worlds will feel like peaceful shelters, testaments to humanity's patience, creativity, and desire for harmony in the stars. Fact 41. Rocks older than Earth herself. Asteroids, those wandering stones that drift silently through the solar system, are older than our planet. Ancient fragments left from the time when the sun was newly born. Future explorers will approach them with gentle curiosity, knowing that each one carries a record of cosmic history deep within its layers. Some will be solid metal, others porous rubble slowly pulled together by gravity's faint touch. Scientists will land softly on their surfaces, using anchoring cables to steady themselves in the near-weightless environment. They'll collect samples of minerals untouched for billions of years, each grain a whisper from the early days of creation. And as they study these primordial stones, humanity will gain a deeper understanding of how worlds are formed, learning from the quiet relics that wandered the void long before Earth existed. Fact 42. Gentle touch. Mining. No explosions. Needed mining in space will look nothing like the noisy, forceful techniques used on Earth. With fragile materials and almost non-existent gravity, future asteroid mining will require a soft, precise approach. Instead of drills and detonations, tiny robotic arms will gently scoop, brush, and gather dust and rock, moving with the delicacy of careful gardeners tending soil. Electrostatic tools may lift fine grains without ever touching them, using small charges to coax material into waiting containers. Light tethers will keep machinery anchored, preventing even the faintest recoil from sending it drifting away into the void. Every action will be slow, methodical, and quiet, shaped by respect for the environment and the physics of deep space. And through this gentle touch, humanity will learn to gather resources in harmony with the cosmos, taking only what is needed, and doing so with care. Fact 43. Water, harvested from primitive worlds. Many asteroids hold small but precious reserves of water locked within their minerals. In the future, explorers will journey to these quiet worlds to gather this ancient ice, not with haste, but with gentle, deliberate care. Specialized warm probes will glide into the rock, slowly releasing their heat to melt tiny pockets of frozen water. The liquid will be guided into waiting tanks, where it will be purified and stored for travel. This water will sustain life far from Earth, becoming drinking water, nourishing hydroponic gardens, and providing hydrogen and oxygen for fuel. Each drop collected will feel like a gift from the oldest reservoirs of the solar system, untouched since the earliest days of planetary formation. And as we draw from these primitive worlds, we'll be reminded of how life depends on the softest, simplest resource: water drifting quietly through space. Fact 44. Metals gathered from ancient cores. Some asteroids are remnants of long-lost protoplanets, shattered worlds whose molten cores cooled into solid metal long before Earth took shape. These metallic asteroids drift slowly, glinting faintly as sunlight catches their surfaces. Future missions will approach them with a sense of deep respect, knowing they carry iron, nickel, and platinum group metals forged in the heart of ancient cosmic storms. Mining these cores will be meticulous work. Robotic arms will shave thin layers from the surface, or magnetic fields will draw metallic grains into collectors. Each piece harvested will be incredibly pure, requiring little refinement. These metals will become the beams of space habitats, the hulls of starships, and the tools used across distant colonies. And with each quiet extraction, humanity will draw closer to understanding the long, turbulent history written into these celestial remnants. Fact 45. Refineries floating in silent orbits. Rather than hauling raw materials back to Earth, future settlers will build refineries directly in space. Calm, drifting platforms that process metals, water, and minerals in microgravity. These floating factories will hum softly as they melt, sort, purify, and transform asteroid fragments into usable components. Without gravity pulling impurities downward, materials will separate with elegant simplicity, forming clean layers ready for shaping. Inside the refineries, robotic systems will move with slow precision, guiding molten streams through channels that glow like thin ribbons of fire. Workers will monitor everything from warm observation decks, watching the quiet ballet of machines as they create beams, sheets, and coils of refined metal. And from these peaceful foundries, a new interplanetary economy will emerge, one built not on noise or haste, but on patience and the gentle efficiency of space itself. Fact 46. Asteroid tugboats guiding wayward stones. In the future, small robotic tugboats will roam the asteroid belt, gently guiding drifting rocks onto safe, predictable paths. These machines will use tiny bursts of ion propulsion, gently nudging asteroids without disturbing their natural structure. Their movements will be slow and deliberate, like caretakers tending to ancient travelers in the dark. Sometimes they'll redirect a stone toward a mining station. Other times, they'll simply adjust its orbit so it poses no danger to nearby habitats or routes. Their lights will blink softly in the darkness, faint signals marking quiet, purposeful work. Over time, these tugboats will create a beautifully ordered dance among the rocks, shaping the belt into a safe corridor for exploration. And with every gentle adjustment, humanity will make the cosmos feel just a little more welcoming. Fact 47. Turning asteroids into protective shields. As our space settlements grow, some asteroids will be transformed into natural shields, guardians that protect habitats from radiation and micrometeorites. Engineers will hollow them out carefully, leaving strong stone shells that can be positioned near vulnerable stations. These giant rocks will absorb the constant drizzle of space debris that drifts through the solar system, sheltering the delicate habitats behind them. Solar-powered thrusters will keep them in place, adjusting their orientation with calm precision. From afar, these protective asteroids will appear like silent sentinels, floating peacefully beside the shimmering walls of space stations. Inside, sensors will monitor subtle vibrations and impacts, translating them into gentle data streams for researchers studying the environment. And as these ancient stones take on new purpose, humanity will learn once again to work with nature's oldest materials in the quiet of the cosmic sea. Fact 48. Hollowed sanctuaries for deep space travel. Some asteroids will be reshaped into deep space habitats, hollowed sanctuaries, drifting far from the familiar pull of planets. Their thick outer shells will provide natural shielding, while their interiors will be transformed into warm, life-supporting chambers. Artificial gravity may be created through slow rotation, giving residents the comfort of stable footing even in the middle of the void. Inside these sanctuaries, soft lights will simulate gentle daylight, washing across communal areas where travelers rest on their long journeys. Small gardens will grow in circular plots, supported by recycled water and carefully balanced ecosystems. These drifting homes will move quietly along their plotted routes, carrying explorers between distant settlements. Each one will feel like a peaceful retreat, a moving refuge where people can sleep, study, and dream as the stars drift endlessly outside. Fact 49. Factories that hum in microgravity. In the quiet of deep space, far from planetary pull, future factories will float in gentle orbits, peaceful workshops where microgravity becomes a powerful ally. Without the tug of gravity, delicate materials can be shaped with extraordinary precision. Metals cool into flawless forms, crystals grow in perfect symmetry, and fragile components assemble without sagging or warping. Inside these factories, robotic arms will move with unhurried grace, guiding streams of molten alloys or carefully aligning microscopic structures. The hum of machinery will be soft and constant, a calming rhythm that echoes through wide, weightless chambers. Engineers will observe from serene control rooms, adjusting processes with the lightest touch. And from these floating foundries, new technologies will emerge, stronger, cleaner, and crafted with the quiet patience of a world without weight. Fact 50. Asteroids as stepping stones to everywhere. As humanity stretches into the solar system, asteroids will become gentle waypoints, stepping stones scattered across the cosmic sea. Some will host small depots stocked with fuel and supplies. Others will house research outposts or safe harbors where ships can pause during long journeys. Each one will feel like a tiny island in an endless ocean of stars. Routes between these stones will form naturally, shaped by gravity and the slow patterns of orbital motion. Travelers may spend a few days resting inside a hollowed asteroid, watching distant sunlight glimmer on its rough interior walls. Outside, navigation beacons will blink softly, marking paths that lead to Mars, Jupiter, or even beyond. And with every new waypoint, the solar system will feel less like a vast frontier and more like a connected archipelago of quiet, drifting worlds. Fact 51. Drifting in the skies of Jupiter. One day, explorers may drift through the upper atmosphere of Jupiter, carried by sturdy aerostats, floating platforms designed to hover in the giant planet's calmer layers. Here, The winds move in vast, swirling bands, but at certain depths, the pressures and temperatures become surprisingly gentle. Platforms will rise and fall with hydrogen balloons, staying aloft as though held by an invisible hand. Through reinforced windows, travelers will watch Jupiter's clouds roll beneath them like endless waves of peach, cream, and amber. Lightning will flicker far below, illuminating the depths with silent bursts of pale light. Instruments will quietly measure the composition of the air, gathering secrets from a world with no solid ground. And drifting in those colossal skies, humanity will feel humbled, a small presence floating in the atmosphere of a gentle giant. Fact 52. Europa's hidden ocean, warm and waiting. Beneath Europa's icy shell lies one of the most mysterious oceans in the solar system. A vast, dark sea kept warm by gentle tidal heating deep within the moon's core. Future explorers will drift above its cracked surface, listening to the soft groans of shifting ice plates. Eventually, robotic submersibles will melt through the frozen crust, descending into waters that have been untouched for billions of years. Down there, in the silent blackness, instruments will glide through currents warmed by underwater vents. Tiny particles will drift past like slow snow, illuminated by soft lights from the submersible's hull. Scientists will watch in awe, wondering whether simple life might have found refuge in these quiet depths. And as each shimmering image rises to the surface, Europa will reveal a little more of its hidden, ancient heart. Fact 53. Ganymede's magnetic whisper. Ganymede, the largest moon in the solar system, carries something remarkable: its own magnetic field, a rare trait among moons. In the future, explorers will study this gentle magnetic bubble with instruments that hover softly above the icy terrain. As they measure its subtle pulses, they'll uncover clues about a liquid ocean buried deep below, swirling slowly around a metallic core. On the surface, the ground will appear etched with delicate ridges and grooves, shaped by ancient tectonic shifts. Rovers will glide across these patterns like careful brushes tracing an artist's work. Above them, the magnetic field will hum faintly through their sensors, a calm signature of the moon's inner life. And with every reading, Ganymede will feel less like a silent moon and more like a world quietly keeping its own secrets. Fact 54. Callisto, a quiet refuge far from trouble. Farther from Jupiter's intense radiation lies Callisto, a calm, ancient moon whose surface has barely changed in billions of years. In the distant future, human outposts may settle here first, drawn by the moon's relative safety and gentle stillness. Habitats will nestle into wide plains of dark ice and rock, shielded by natural serenity rather than harsh defenses. Researchers may step outside in protective suits, their boots crunching softly on terrain older than almost anything in the solar system. Above them, Jupiter will hang enormous in the sky, glowing like a muted lantern. Life on Callisto will be slow and peaceful, shaped by long nights and distant sunlight. And in this unchanging quiet, humanity will find a sanctuary, a tranquil resting point on the edge of Jupiter's domain. Fact 55. Saturn's rings. Future laboratories of ice. Saturn's rings, delicate and shimmering, are built from countless icy fragments drifting in gentle harmony. In the future, robotic laboratories may glide among these particles, studying their composition with quiet curiosity. Instruments will reach out to capture tiny grains of ice and rock, each one a frozen memory from the era when planets were still forming. These labs will drift softly between ringlets, riding the subtle gravitational currents that shape the bands. Engineers will monitor them from distant stations, watching as they slip like silent boats through a glittering river of pale light. The soundscape will be one of near-perfect quiet, only the faint hum of machinery and the soft tap of particles against reinforced hulls. And through this graceful exploration, Saturn's rings will become not just a sight to behold, but a gentle classroom for understanding the origins of the solar system. Fact 56. Titan's orange mist and methane seas. Titan, Saturn's largest moon, will one day welcome explorers into its thick, hazy atmosphere. Here, the sunlight is faint and golden, filtered through dense layers of orange mist. Future travelers will walk across frozen plains where rivers of liquid methane carve smooth channels into the ground. Above them, the sky will glow with soft amber light, creating a dreamlike world unlike any other. Specialized suits will keep explorers warm in the extreme cold, and small flyers will drift through the dense air, taking advantage of Titan's thick atmosphere to soar with slow, effortless motion. Scientists will study the chemistry of its seas, wondering how such an alien environment might mimic the earliest stages of life. And in the quiet of Titan's strange twilight, humanity will learn how varied and beautiful distant worlds can be. Fact 57. Enceladus and its gentle plumes. Enceladus may be small, but it carries one of the most intriguing wonders in the solar system: icy plumes that rise from its south pole like soft fountains. In the future, spacecraft will fly through these plumes with delicate precision, collecting particles of water, minerals, and organic molecules released from the world's hidden ocean. These particles will sparkle in the sunlight as they drift upward, forming a thin, graceful arc that stretches into space. Instruments aboard passing ships will analyze the plumes in real time, searching for hints of life or the chemical recipes that make it possible. Landing craft may touch down near the cracks where the plumes originate, listening to the faint tremors beneath the ice. And as Enceladus releases its whispered secrets into the void, humanity will feel the gentle promise of discovery carried on every drifting particle. Fact 58. Floating platforms above Saturn's clouds. One day, humanity may drift high above Saturn's cloud tops aboard enormous floating platforms. These gentle structures would hover in layers of the atmosphere where pressure is calmer, carried by buoyant gases and steady winds. Their hulls would gleam softly in the filtered light, reflecting the muted gold and cream bands of the giant planet below. Inside, the air would be pressurized and warm, offering travelers a peaceful vantage point above a world without solid ground. Sensors outside would record the swirl of storms and the deep rotations that define Saturn's rhythm. Occasionally, lightning might flicker far beneath, illuminating the undersides of the clouds with pale flashes no louder than a whispered breath. And drifting on these suspended platforms, explorers would feel as though they were floating through a dream, carried gently above one of the solar system's most majestic atmospheres. Fact 59. Uranus, a pale, tilted mystery. Uranus, with its soft blue hue and sideways rotation, remains one of the quiet mysteries of our solar system. In the future, spacecraft will journey there with calm determination, entering orbit to study its serene, pastel atmosphere. From above, the planet will appear as a smooth sphere of pale cyan, its storms subtle and slow-moving, its rings faint and wispy, like strands of frost. Explorers may release drifting probes into the upper layers, where gentle winds circle the planet in long, elegant patterns. Instruments will listen for faint signals from deep within, hoping to understand the icy mantle that surrounds its hidden core. And as humanity watches this tilted world turn through its long seasons, each lasting decades, Uranus will teach us that even quiet planets hold stories worth unfolding with patience and care. Fact 60. Neptune's deep blue winds of tomorrow. Farther still, Neptune waits, a world of deep sapphire clouds and powerful yet strangely graceful winds. Future orbiters will arrive after long, tranquil voyages, settling into place to observe the planet's luminous storms. Through thick windows, travelers might watch pale streaks drift across Neptune's surface, carried by winds that move faster than any on Earth, yet appear slow and soothing from high above. Robotic probes will explore the upper atmosphere, drifting like delicate seeds on a breeze. Their instruments will taste the methane-rich air and listen to the soft rumble of hidden weather patterns. Even the distant sun will cast a faint, blue-tinged glow across the planet, creating an otherworldly light few have ever seen. And as Neptune turns beneath them, wrapped in endless gradients of blue, explorers will feel a peaceful awe, humbled by the quiet majesty of the outermost giant. Fact 61. Artificial gravity for peaceful sleep. As humans begin living far from Earth, artificial gravity will become a gentle necessity. In future habitats, entire sections of a station may rotate slowly, creating a soft downward pull that mimics the familiar weight of home. Inside these curved corridors, people will walk, stretch, and rest with the comfort of gravity beneath their feet, even as the stars drift endlessly outside. At night, residents will slip into warm sleeping areas where the artificial gravity is tuned just right, enough to soothe the body, but light enough to ease every muscle. Heartbeats will slow, breaths will deepen, and the quiet hum of the rotating structure will blend into a lullaby-like rhythm. And in this steady embrace of engineered gravity, humanity will find peaceful rest, even while sailing through the silence of deep space. Fact 62. Hydroponic gardens in a slow, green glow. Across future spacecraft and habitats, hydroponic gardens will offer calm pockets of life, glowing softly under gentle lamps. In these floating green sanctuaries, roots will trail through nutrient-rich water instead of soil, absorbing everything they need in quiet, effortless harmony. Leaves will unfurl in slow motion, their edges curling slightly in the lowered gravity, catching every beam of artificial sunlight. Residents will move quietly between rows of lettuce, herbs, and fruiting vines, tending to the plants that feed them with almost meditative care. Small droplets of water may float briefly before being caught by careful hands or delicate filters, turning even irrigation into a graceful dance. And as these gardens flourish, they will become the beating heart of every habitat, a reminder that even in the coldest reaches of space, life continues to grow. Fact 63. Recycling everything in closed-loop harmony. To thrive among the stars, future communities will perfect the art of recycling, turning every drop of water, every breath of air, and every scrap of material into part of a seamless, closed-loop system. In these environments, nothing will be wasted. Water will condense gently on cool surfaces, returning to reservoirs. Air will flow through quiet filters, refreshed and balanced with each cycle. Even organic matter will be transformed into nutrients for plants. Machines will hum softly as they break down, purify, and reassemble resources, working tirelessly behind the scenes. Residents will take comfort in knowing that every small action contributes to a larger harmony, keeping the habitat alive and in gentle equilibrium. And in mastering these cycles, humanity will learn to live more lightly, not only in space, but perhaps one day back on Earth as well. Fact 64. Breathing air made from starlight energy. In the future, the air that fills our space habitats will be crafted from the quiet power of starlight. Solar arrays will capture sunlight and convert it into clean energy, which will then drive gentle electrolysis systems that split water into oxygen and hydrogen. The oxygen will flow softly through ducts into living quarters, creating a warm, breathable atmosphere even in the deepest reaches of space. Residents will hardly notice the process. The hum of the machinery will be low and calming, blending into the natural rhythm of station life. What they will feel, instead, is the comfort of steady, nourishing air that seems to glow with the very essence of sunlight. And with each breath taken beneath the stars, humanity will be reminded that even far from Earth, life can flourish with quiet grace. Fact 65. Homes that shift gravity. Like day and night, gravity may one day become something we adjust as naturally as lighting a room. In advanced habitats, entire living spaces will be built on rotating rings or adjustable floors that can gently alter gravity's pull. In the daytime, families might enjoy Earth-like gravity as they walk, cook, and exercise. During night, the gravity could soften, easing strain on their bodies and helping them drift more peacefully into sleep. Residents will feel the shift almost imperceptibly, a slow transition, like sinking into a warm bath. Children born in space might grow familiar with varying gravity patterns, adapting playfully to lighter evenings and steadier mornings. And in these adaptable homes, humanity will learn that gravity itself can become a gentle tool, creating comfort and health in the floating neighborhoods of tomorrow. Fact 66. Quiet robotic helpers in every habitat. Amid the corridors of future stations and drifting colonies, quiet robots will become trusted companions. Not loud machines, but gentle assistants designed to move with soft precision. They'll tidy living spaces, manage air filters, check water levels, and repair systems long before any human notices a flaw. Their motions will be smooth and deliberate, guided by advanced sensors that keep them aware of every drifting cable and floating droplet. Some will be small and round, gliding along walls like peaceful cleaners. Others will resemble graceful arms that fold away neatly when not needed. They won't speak loudly or demand attention. Instead, they'll offer subtle reminders, soft tones, and thoughtful help in the background of daily life. And in the quiet partnership between humans and these robotic caretakers, space habitats will feel safe, calm, and beautifully in harmony. Fact 67. Cosmic classrooms for children of the future. In the centuries ahead, some children may grow up never knowing an earthbound sky. Their classrooms will be quiet chambers aboard stations, moons, and drifting habitats, places where learning happens beneath soft lights and panoramic windows that overlook the stars. Lessons will unfold slowly, shaped by curiosity and calm exploration rather than hurry. Teachers might guide students through simulations of planetary geology, or lead them into hydroponic gardens where they learn how life thrives in closed-loop ecosystems. Outside, rotating habitats will create gentle gravity, allowing children to play, run, and glide through curved parks designed specifically for spaceborne youth. And in these cosmic classrooms, education will feel like a journey through wonder, preparing a new generation to move gracefully among the worlds their ancestors once only dreamed of. Fact 68. Art inspired by light without shadows. In the weightless corners of future habitats, artists will find inspiration in the way light travels without interruption. Without a single direction for gravity to dictate shading or perspective, art will evolve into something entirely new. Sculptures may float freely, rotating slowly so that every angle becomes part of the experience. Paintings might stretch across curved surfaces, illuminated by soft, even lighting with no harsh shadows. Musicians, too, will discover that sound behaves differently in controlled atmospheres, carrying with a clarity that feels almost otherworldly. Dancers may drift through performance spaces where they can rise and twirl with gentle pushes, their bodies moving in ways impossible on Earth. And as art transforms in these floating worlds, humanity will remember that creativity thrives wherever imagination has room to breathe, even among the stars. Fact 69. Medicine floating in microgravity labs. In future medical stations, doctors will work in softly lit laboratories where microgravity allows them to craft treatments with extraordinary precision. Cells will grow differently in weightlessness, forming structures that help scientists understand diseases in ways never possible on Earth. Researchers will watch them divide and drift, observing how the absence of gravity reveals hidden patterns. Surgeons may use magnetic fields and gentle suction tools to perform delicate procedures while patients rest comfortably in controlled environments. Medicine will become both quieter and more elegant, guided by robotics that move with a calm, steady grace. And through these floating laboratories, humanity will develop cures and innovations that ripple back to Earth, healing people across worlds, connected by one continuous thread of compassion. Fact 70. The first space-born generations. One day, the first children born beyond Earth will take their earliest breaths in the gentle hum of a habitat drifting far from home. Their sense of up and down will feel different from ours, shaped not by Earth's gravity, but by the soft pull of rotating stations, or the lightness of lunar and Martian worlds. As they grow, their bodies will adapt with natural grace, longer strides in low gravity, playful leaps that rise higher than any earthbound jump. Their lullabies will be sung beneath artificial skies, their playgrounds curved around habitat walls, their memories touched by the constant presence of stars. They'll learn to read by the glow of recycled sunlight and dream of worlds they've never visited but are free to explore. And these children will become the first true citizens of many worlds, carrying humanity gently into a future woven across the solar system. Fact 71. Mapping the galaxy in gentle sweeps. In the future, drifting observatories will fan out across the solar system, each one scanning the sky in slow, sweeping motions. These observatories will use ultra-precise instruments to map the Milky Way with calm, deliberate care, charting the positions of stars, the hum of distant pulsars, and the faint trails of wandering objects between the suns. Data will stream back in soft pulses of light, traveling across millions of kilometers to reach listening stations woven throughout human settlements. Scientists will translate this information into elegant maps, with entire star systems arranged like constellations on parchment. And as humanity gazes upon these vast, intricate charts, we'll feel a new kind of connection, a shared knowledge of where we are in the cosmic sea, mapped with patience and wonder. Fact 72. Listening for whispers from distant worlds. Across quiet stations, floating far from Earth's noisy electromagnetic haze, astronomers will tune delicate receivers toward the stars. These instruments will listen for the softest signals, faint radio hums, rhythmic pulses, and subtle variations that hint at storms, atmospheres, or even oceans on faraway planets. The universe speaks in gentle whispers, and future listeners will be ready to hear them. In these listening outposts, the rooms will be dim, illuminated by the screens that glow with incoming data. The signals will arrive as patterns of light and sound, tiny signatures of worlds light years away. Scientists will analyze them in peaceful collaboration, tracing each pattern back to its source across the dark. And with every whisper captured from the void, humanity will feel a quiet closeness to planets we have not yet seen, but may one day visit. Fact 73. Studying life in simulated alien oceans. In the serene laboratories of future habitats, scientists will create carefully controlled pools that mimic the oceans of distant moons. These simulated seas will be chilled to Europa-like temperatures or enriched with the chemicals found beneath Enceladus's icy crust. Inside them, tiny organisms, engineered or naturally discovered, will drift in slow, graceful motions, teaching researchers how life might survive far from the warmth of Earth. Scientists will observe these creatures under gentle blue lights, watching as they adapt to strange pressures, exotic chemistries, and dim illumination. Robotic tools will move through the water with soft precision, taking samples without disturbing the delicate environments. And through these quiet experiments, humanity will gain a deeper understanding of life's resilience, preparing us to recognize even the faintest signs of biology in the alien oceans we explore. Fact 74. Telescopes at the edge of the solar system. Far beyond the orbit of Neptune, humanity may someday place telescopes where the sun appears only as a bright star. In this deep, cold region, the silence is perfect, free from the noise of solar radiation and the interference of planetary magnetic fields. These distant observatories will drift slowly, drinking in faint streams of light from the earliest galaxies. Their enormous mirrors will unfold like metallic petals, reflecting stars that existed when the universe was still young. Signals collected here will travel immense distances to reach Earth and scattered settlements across space. Scientists will interpret them with awe, transforming them into images of cosmic dawns and ancient structures. And from this quiet frontier, we will look farther back in time than ever before, listening to the universe's earliest stories. Fact 75. Dark matter experiments in deep quiet. To understand the invisible fabric of the cosmos, researchers will build delicate experiments in remote, well-shielded locations. Perhaps inside hollowed asteroids or distant moons where cosmic noise is minimal. These experiments will watch for rare interactions between ordinary matter and the mysterious particles that seem to shape galaxies. Sensitive detectors will sit in chambers lined with protective layers, surrounded by the deep hush of space. They may glow faintly when struck by a passing particle, each flicker a clue in the vast puzzle of dark matter. Researchers will monitor the readings patiently, knowing that discoveries may take years or decades. And in the stillness of these dark laboratories, humanity will draw closer to understanding the unseen forces that guide the stars. Fact 76. Quantum networks stretching across worlds. In the future, communication between planets will become quieter, faster, and more graceful than anything we know today. Quantum networks, delicate webs of entangled particles, will allow information to echo instantly across unimaginable distances. Though full teleportation of messages may remain a distant dream, these early networks will offer remarkable precision, letting distant stations remain gently synchronized in their measurements and timing. Within softly lit control rooms, scientists will adjust shimmering arrays of quantum sensors calibrated with exquisite care. Each device will respond to tiny shifts in entanglement, like strings of a cosmic instrument humming together across space. Messages will travel not through loud radio bursts, but through silent patterns of correlation, linking habitats with serene reliability. And as these networks weave through the solar system, humanity will feel more connected than ever, bound by threads of quiet light. Fact 77. Cosmic weather. Forecasting for spacefarers. Just as sailors once watched the winds and clouds, future spacefarers will rely on gentle forecasts of cosmic weather. Scientists will study streams of charged particles flowing from the sun, mapping their shifting patterns like tides in an invisible sea. From calm observatories built on moons and stations, they'll track solar flares, radiation bursts, and the movements of dust and plasma through interplanetary space. Large digital maps will glow softly in operations centers, displaying elegant curves that show safe routes for travelers. Crews preparing for long journeys will listen to forecasts the way pilots do today, not with fear, but with patient awareness. When a storm approaches, ships will adjust their paths or shelter behind protective fields until the radiation quiets again. And through this gentle observation of cosmic weather, traveling the solar system will become as natural as navigating Earth's ancient seas. Fact 78. Measuring time, where gravity bends. In the future, humanity will learn that time itself flows differently among the stars. Clocks on planets, moons, habitats, or drifting ships will tick at slightly varied rhythms depending on the gravity and motion around them. Scientists will study these subtle curves in time with breathtaking delicacy, using atomic clocks so precise they can sense the faint tug of nearby masses. These clocks will sit inside calm laboratories, their vibrations measured by quiet lasers that trace movements smaller than a stray grain of dust. Data will drift between stations, revealing how time stretches near massive worlds and relaxes in the emptiness of deep space. And as we chart these gentle shifts in the flow of seconds, we'll gain a deeper appreciation for the strange, poetic fabric of space-time, a tapestry woven silently beneath every step we take among the stars. Fact 79. Capturing stardust from passing comets. In the peaceful future of space exploration, small spacecraft will drift beside passing comets, gathering tiny grains of stardust that trail behind them. These ancient particles, older than Earth itself, will float gently into collectors made of airy, delicate materials that slow them without harm. The stardust will settle like snowflakes onto soft surfaces, preserved exactly as it traveled through space for billions of years. Inside the ships, scientists will study each grain under warm, diffuse lights, observing the minerals and traces of organic molecules locked inside. Each speck will feel like a cosmic time capsule, a whisper from the era before planets took shape. And as humanity learns from these fragile travelers, we'll deepen our connection to the early universe, one drifting particle at a time. Fact 80. Learning from worlds that never warmed. Some of the most mysterious objects in the solar system are the ones that never became full planets. The icy bodies of the Kuiper Belt drifting far beyond Neptune's reach. In the future, robotic explorers will travel calmly to these worlds, landing softly on surfaces that have remained unchanged for eons. Here, the cold is so deep and gentle that chemical reactions move at glacial speeds, preserving the past with remarkable clarity. Instruments will examine the frozen methane, nitrogen, and water locked into these surfaces, noting how their patterns reveal the history of the early solar system. These distant objects, untouched by warmth or storms, will become quiet teachers, offering insights into what our cosmic neighborhood looked like before Earth's oceans, mountains, and life. And as we learn from these ancient, unmoving spheres, we'll sense the stillness that shaped the earliest chapters of our story. Fact 81. The first ships beyond Oort's lonely border. Far past the planets, past the Kuiper Belt, past even the distant comets, lies the Oort cloud, a vast, dark region where sunlight fades to a cold whisper. One day, humanity will send ships beyond this lonely frontier. These vessels will travel in serene arcs, powered by fusion engines or gentle light sails that capture the last thin traces of starlight. On board, explorers will live in quiet habitats, insulated from the cold emptiness outside. Their windows will show scarcely any stars, just faint glimmers scattered across an ocean of black. Each passing day will carry them farther from the sun's comforting warmth and deeper into the true vastness of interstellar space. And as they cross the invisible threshold of the Oort cloud, humanity will take its first peaceful step toward other stars. Fact 82. Laser-driven craft sailing to neighboring stars. In the quiet centuries ahead, humanity may launch tiny star-bound probes, pushed not by engines, but by beams of gentle, perfectly aimed light. These laser-driven craft will unfurl sails thinner than a whisper, so delicate they shimmer when touched by even the faintest photon. From distant arrays orbiting Earth or the Moon, steady streams of laser light will push these sails outward, accelerating the probes to astonishing speeds. There will be no roar, no flame, only the silent pressure of light guiding them across the darkness. As they drift farther away, the beams will grow, fainter, until the probes fly on momentum alone, crossing the gulf between stars with unhurried grace. And as these tiny travelers slip into interstellar space, they will carry humanity's curiosity on wings made of light. Fact 83. Slumbering passengers on generational journeys. When humanity finally builds ships large enough for interstellar voyages, some travelers may choose to sleep through the centuries. These generation ships will carry softly glowing chambers where passengers rest in gentle stasis, wrapped in warm, protective fields or deep hibernation. Time will pass slowly for them, a long, calm drift through the dark, their dreams unfolding beneath artificial stars. Around them, the ship will operate in quiet rhythms. Hydroponic gardens will grow in enclosed forests. Tiny maintenance drones will glide through corridors. Rotating habitats will provide steady, comforting gravity for the waking crew. Generations may rise, learn, and care for the vessel while others sleep peacefully, waiting for the distant day they awaken near a new sun. And as these slumbering passengers dream their way between the stars, humanity will weave itself into the long, serene flow of cosmic time. Fact 84. Star maps etched across centuries. For travelers leaving the safety of the solar system, star maps will become treasured companions. Guides carved not on paper, but encoded in shimmering digital crystals designed to last centuries. These maps will catalog the shifting dance of stars as they move slowly through the Milky Way, ensuring that future generations aboard deep space ships always know where they are. In soft-lit navigation rooms, explorers will watch holographic skies unfold around them, revealing the constellations not as we see them from Earth, but as they appear from far-flung vantage points. Each star will shine with gentle accuracy, its position updated in real time as ships drift deeper into the galaxy. And as centuries pass, these evolving maps will become quiet records of humanity's journey, a glowing trail through the endless night. Fact 85. The soft glow of fusion torch drives. Far in the future, when humanity begins traveling between stars with more confidence than fear, our ships may be powered by fusion torch drives, engines that burn with the quiet intensity of captured starlight. Unlike roaring rockets, these drives will emit a steady, controlled glow, like a soft lantern guiding a vessel through the darkness. Their gentle thrust will build over long stretches of time, allowing ships to accelerate smoothly across vast distances without jarring motion. Inside the habitats, passengers will hardly notice the propulsion. They'll walk through warm corridors, tend gardens beneath artificial suns, and watch the faint shimmer of the drive reflected in polished surfaces. Outside, the engine's glow will trail behind like a thin ribbon of pale fire, visible only as a whisper against the black. And with each steady pulse of fusion light, the ship will drift closer to distant stars, carried by the quiet heart of controlled fire. Fact 86. Probing the quiet of interstellar space. Between the stars lies a realm more silent than any earthly wilderness, a place where even dust becomes scarce and particles drift with almost unimaginable patience. Future probes will venture into this interstellar quiet, their delicate sensors tuned to capture the faint hum of cosmic rays, magnetic fields, and ghost-like atoms drifting between star systems. Wrapped in insulated shells, these probes will measure temperatures colder than any natural place within the solar system. They'll listen for shock waves from ancient supernovae, study the density of interstellar clouds, and follow subtle gradients of gas and dust that shape the galaxy's slow evolution. As the data streams back toward humanity, each gentle transmission will be like a heartbeat from the deep unknown, a reminder that even the emptiest regions of space carry stories waiting to be heard. Fact 87. Exploring the planets of Proxima Centauri. If our first interstellar destination is the small red star Proxima Centauri, future explorers may arrive in a system filled with quiet mysteries. Proxima's planets will be dimly lit worlds, warmed by a star that glows more like a ruby ember than a bright sun. Ships will enter orbit gently, their sensors reading atmospheres, magnetic fields, and the faint signatures of weather drifting across alien skies. One planet may hold oceans shielded by thick clouds. Another might be a rocky sphere, locked with one face forever turned toward the star. Rovers will roll slowly over unfamiliar terrain, their lights glowing softly against surfaces untouched by life from Earth. And as humanity stands beneath Proxima's muted light, we will feel both the strangeness and the beauty of being visitors in a new, stellar neighborhood. Fact 88. Observatories between the stars. As humanity drifts farther from the sun, we may someday anchor observatories in the vast spaces between star systems. Quiet platforms, suspended in a region so empty that light travels unchallenged for trillions of kilometers. These observatories will float alone in the gentle dark, powered by fusion cores or slow, reliable reactors that hum like distant heartbeats. Their instruments will open wide to the cosmos, unhindered by planets, atmospheres, or solar noise. They'll collect faint glimmers from galaxies billions of years old, Measure gravitational waves passing silently through the void and study the universe in its most pristine form. Inside, warm control rooms will glow softly, lit by panels that translate data into graceful curves and star maps. The scientists stationed there will live peaceful, contemplative lives, surrounded by nothing but pure starlight. And in that calm emptiness, humanity will learn to observe the universe with a clarity Earth could never offer. Fact 89. The long drift into the galactic spiral. Each deep space ship that ventures beyond the sun's reach will slowly fall into the greater motion of the Milky Way. The long, unhurried drift of stars orbiting the galactic center. Even though the movement is vast and gentle, passengers aboard these ships will sense the quiet majesty of joining a journey that has lasted billions of years. They might look through observation windows and see the spiral arms stretching faintly around them, glowing with star clusters and drifting nebulae. The ship's engines will hum softly, adjusting course with a patience measured not in hours, but in generations. And as humanity glides deeper into the galaxy's spiral, we will come to understand that we are part of a much larger rhythm, a cosmic rotation that began eons before our first spark of curiosity. Fact 90. Messages sent through the dark for millennia. In a future where stars become stepping stones for exploration, humanity will send quiet messages through the dark. Transmissions designed to drift for centuries or even millennia before reaching their destinations. These signals will be crafted with care. Soft pulses of light, encoded radio waves, or beams of entangled particles carrying knowledge, greetings, or gentle reminders from home. Receivers on distant colonies will listen patiently, knowing that each message is a thread connecting them across time as much as distance. Some signals may arrive long after the senders are gone, yet still offer comfort. A voice preserved in the fabric of space. And as these messages travel through the silent dark, they will become part of a galaxy-wide conversation, reminding every colony and every traveler that no matter how far we roam, we remain connected. Fact 91. Archives preserved in crystal memory. In the distant future, humanity will store its knowledge not just in books or servers, but in shimmering crystal archives, durable memory structures encoded with light. These crystals will hold countless pages of history, science, art, and song, preserved in patterns so intricate they resemble frozen starlight. Entire libraries will fit inside a handful of glowing shards, each one capable of lasting longer than civilizations. Archivists will tend to them in quiet chambers, lit by gentle, ambient hues. They'll scan the crystals with beams of soft laser light, watching information unfold like blossoms in slow motion. These records will accompany starships, colonies, and drifting habitats, ensuring that no matter how far humanity travels, our stories and wisdom travel with us. And as these luminous archives pass from generation to generation, they will become cherished lanterns of memory, shining softly through the ages. Fact 92. Art carried. Across light years, as our species spreads among the stars, we will bring not only tools and technology, but the poetry of our cultures. Starships and distant settlements will carry digital galleries, woven textiles, hand-sculpted figures, and musical recordings from Earth's many traditions. Some travelers will create new forms of art along the way. Paintings inspired by alien horizons, music shaped by the hum of life support systems, dances that drift in low gravity like gentle waves. In quiet communal rooms, settlers will gather to share these works, letting ancient Earth melodies blend with new creative expressions born far from home. Murals may decorate habitat walls, depicting the landscapes of Earth alongside visions of distant moons. And through these floating galleries of creativity, humanity will remember that beauty is as essential as air, something we carry with us, no matter how far we journey. Fact 93. Cultures blossoming beyond Earth. In space, human culture will evolve with tender uniqueness. Each settlement, whether on Mars, in a lunar city, or aboard a drifting cylinder, will develop traditions shaped by its environment. Some may celebrate the moment when artificial dawn lights first brighten. Others may mark the slow arrival of a supply ship as a community festival. Children might grow up playing games adapted to low gravity, learning dances that glide and swirl through curved corridors. Languages, too, will shift ever so slightly, influenced by new rhythms and experiences. Storytellers will weave tales about their home planets, long voyages, and the stars that cradle their habitats. Holidays will emerge that honor both Earth-born ancestors and the new worlds that shelter humanity's expanding family. And as these diverse cultures blossom quietly across the solar system, we will discover countless new ways of belonging among the stars. Fact 94. Shared sky festivals on distant worlds. As humanity settles among planets and moons, new traditions will bloom beneath unfamiliar skies. Shared sky festivals will become moments where entire communities gather to watch celestial events that never occur on Earth. On Mars, settlers might celebrate the long twin shadows cast by Phobos and Deimos as they glide overhead. On the Moon, people may gather during Earthrise, watching our blue world lift above the horizon like a luminous lantern. These festivals will be quiet, peaceful celebrations. Families will sit along observation decks, wrapped in warm suits or blankets, listening to soft music carried through the thin air or sealed habitats. Children will trace constellations that look different from those on Earth, learning how the stars shift as you move from world to world. And each festival will gently remind every participant that even across vast distances, we share the same cosmic sky. Fact 95. Interworld languages born from necessity. As humans live and work across distant worlds, communication will evolve in subtle, beautiful ways. New dialects may form aboard rotating habitats, blending Earth languages with words created to describe life in microgravity. Lunar settlers might speak with rhythms shaped by short, efficient phrases suited for communication through helmets and comm systems. Martian children may invent terms inspired by dust storms, low gravity, and the soft glow of their evening skies. Over time, entirely new interworld languages may emerge. Gentle hybrids designed for clarity between colonies separated by millions of miles. These languages will carry the softness of shared experience, built from cooperation rather than competition. And through each new word, humanity will express its expanding identity, weaving together countless voices into a single interconnected tapestry across the solar system. Fact 96. The ethics of expanding. Among the stars. With every new frontier, humanity will pause to reflect on how to explore with care. Ethical councils will form across settlements, guiding decisions about how to approach untouched moons, ancient ice, or fragile ecosystems. These councils will meet in calm, softly lit chambers, discussing how to balance our curiosity with respect for the worlds we touch. Their conversations will drift gently from scientific concerns to philosophical questions. What does it mean to be a good visitor in a universe full of silent landscapes? How do we protect potential life forms we haven't yet discovered? What responsibilities do we carry as a species capable of shaping worlds? And in these thoughtful deliberations, humanity will learn to explore, not with conquest, but with compassion, stepping softly among the stars. Fact 97. Guardians of fragile new ecosystems. As humanity expands into the solar system, we will encounter environments that are delicate, ancient, and unlike anything on Earth. Future settlers will become caretakers of these worlds, protecting their thin atmospheres, icy oceans, and quiet geological rhythms. Ecologists and engineers will work side by side, monitoring chemical balances, shielding habitats from contamination, and ensuring that human presence never overwhelms the natural silence of each world. They'll listen closely to the soft signals emerging from alien soils and frozen lakes, learning how subtle changes ripple through unfamiliar ecosystems. Every adjustment, every new greenhouse, every mining operation, every landing craft will be planned with gentle precision, guided by the desire to preserve what is unique. And in nurturing these fragile environments, humanity will discover a new sense of responsibility, stewardship on a cosmic scale. Fact 98. The Great Library of Many Worlds. One day, humanity will weave together a grand network of knowledge stretching across planets, moons, and drifting habitats, a great library of many worlds. This vast archive will exist both physically and digitally, its volumes stored in crystal memory, quantum records, and traditional texts carried from settlement to settlement. It will preserve not only science and history, but the dreams, art, and voices of countless communities scattered across the solar system. Travelers may step into peaceful reading chambers on Mars, Luna, or deep space stations, where soft lights illuminate shelves filled with stories from many cultures. Scholars will study side by side, linked by gentle communication lines that cross millions of miles. And as this interplanetary library grows, it will become a quiet thread holding humanity together, a shared remembrance of where we began and the wonders we've come to know. Fact 99. A galaxy filled with quiet human light. In the distant future, as centuries turn into millennia, humanity may spread wider across the galaxy, not as conquerors, but as gentle wanderers. Small outposts will glow softly on distant moons. Space habitats will drift like lanterns along interstellar routes. And generation ships will journey between stars with warm lights shining through their hulls. Across these scattered homes, humans will cultivate gardens, raise families, create art, and share knowledge, carrying the essence of Earth into places where no sunlight has ever reached. Each settlement will shine like a tiny ember in the vast dark, a sign of life moving peacefully through the cosmos. And as these quiet human lights multiply, the galaxy will slowly fill with a soft, shimmering network of hope, a testament to our desire not just to explore, but to belong. Fact 100. Humanity becoming a gentle, cosmic species. In the far future, after countless journeys and generations, humanity may come to see itself not as a visitor in the cosmos, but as a quiet and harmonious part of it. Our settlements will shine softly across many worlds, each one shaped with care, humility, and understanding. We will learn to live with patience, adapting to the rhythms of alien skies and the silence of distant landscapes. Children born under unfamiliar constellations will grow up knowing the stars as neighbors, not mysteries. Shared traditions, stories, and discoveries will connect us across the dark, reminding us that every light we kindle in space comes from the same deeply human spark. And as we drift gently through the galaxy, we will become a species defined by wonder, compassion, and calm exploration. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. May these quiet visions of future worlds soften your thoughts and ease your breathing as you drift toward rest. If you enjoyed exploring these sleepy facts, don't forget to like the video, subscribe, and share in the comments what topic you'd love to fall asleep to next. When you're ready to keep dreaming, tap the end screen to watch the next Sleepy Astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.